We ready? Everybody ready to go? Ready to go. All right. Can everybody hear me? All right. Hello. We are the team that worked on the Op6 software project. My name is Christopher Brown.
I'm Nick Swanson.
Matt Newell.
Tommy tomorrow.
So the goals of Op6 are to connect veterans to each other, to their supporters, and to resources dedicated for veterans. Every day, 22 veterans commit suicide. Approximately 50% of veterans suffer from traumatic brain injuries or post-traumatic stress disorder. These are real issues that affect veterans, and the thing about veterans is that they're a demographic that is not likely to want to seek help because they don't want to come off as if they're needy. So the domain goals are to help them connect with each other, reacclimate to civilian life, and do it in a way that makes it seem like they're not, needy or in need of support. Project specifics for Op6. There's going to be user events that connect users. Okay, we don't want like a system where people connect like Facebook through friends of friends or anything like that. It's just people connect in person. Organizations use this app to represent resources. These resources and these events show up on a map of the local area, so veterans every day they can pop open the app. They can be like, hey, I got an event going on today at like 6 p.m. after work. I'll go to that. It's being hosted by like the Veteran Affairs organization. And then there's also supposed to be a gamification system to provide an incentive for veterans to go to events, to host events, to rate events, go to resources, and things like that.
So a big part of this, for the scope of it, is it's cross-platform. So this is meant to be used on Android and iOS, but it's not really a web application. There's not really going to be a website you can go to. It's predominantly for mobile applications. I need to have an administrative dashboard that is in the web, but that is not by any means meant to be accessed by any users. That's for the company and the administrative side of things. It's not a social network. This cannot be stressed enough. It's not like you go and you like pictures and you toggle around and you play on it. It's meant to be a hub to connect people to one another for interpersonal, real-life, real-world connections. It's geospatial, so since it's not a social networking app, there's no real need to put you in contact with somebody out in California if you're here in Rochester. This is meant to help you link up with people for real-life interaction. You can chat, so you could chat with people you meet at events. You could chat with people who are going to events to talk about the events. You could chat with the person who's hosting the event, and it does support that. That is one of the more social networky things about it, but it's not meant to be a platform where you just sit and type on a keyboard all day, and it is gamified. So in order to get users to keep coming recurrently back, there are ways to earn points, increase your rank, and gamification is a part of the scope of this project. Moving into requirements, so for the users, following in that with scope, we don't really want you to be able to boost up your friends list by just adding people who you see on the app or adding people in events. Your friends list is a group of people that you know. So in order to make a connection, you have to scan in someone's QR code, kind of like you would do in Snapchat if you meet someone, but unlike that, you can't type in someone's username. You need to actually see them and meet with them in person. Now, these are the user requirements. So users can make events, they could host events, they could go to events, and the users interact with their events requirements in that way. They can chat with their friends, they could review resources. Privacy is a very, very big part of our requirements on the user side of things. So a lot of these guys coming from a military background I don't want to use the word paranoid, but their information is very, very sensitive to them. And with everything going on online, a lot of people who I've personally met who are come out of the armed forces, and it is wide to the demographic, don't really like having any type of an online presence. So the ability to really mask yourself is a major, major part of this project. Users have bios, which link into privacy concerns, and it just talks about what they did, where they served, who they are. And then they could also favorite different things like resources, events, etc. And those are our requirements on the user side of things.
So events have an RSVP and attending list. They're created by users and/or high school. Right, so events are, as he mentioned, locations in the vicinity. So if you want to pick a basketball game or something after work, you can set that up. These can be rated by users, and you can report bad events.
Resources are the last of our trifecta of like big requirement blocks. Resources are, like I said before, they're organizations that represent these veteran resources. And then the resources are the physical locations for these offices that you can go to. Like I said before, resources can host their own events, or organizations representing resources host their own events. And users can leave comments and ratings on resources. You know, we hear in the news all the time that like veteran services is messing up. You know, if somebody has like complaints they need to post about their local veteran services center, they should feel free to. Early concerns going into the software development of this project. We are the first team to write code for Op6. So every design choice we make has like effects through the entire lifetime of this project. It affects the next team that works on it, all the users that work on it. So it was really important that we nailed down exactly what we wanted to do and how we wanted to do it, and we made sure that we kept track of like every trade-off we made for each design choice. If we're using this like tech stack, we can't do this, but we do this. And that was a big important part. Another thing is loose requirements. Aside from like the trifecta of requirements we said earlier, those are pretty set in stone. But things like how an individual page works, what kind of data you see on that page every time you load up, what it means like going forward if any of these things need to change. Those things are just really important because, like I said before, this is like completely new, so every change like needs to be adaptable in the case that requirements are changing as well. And like referenced earlier, privacy is a big concern as well. This is an application that when you run it, it's going to track where you are, so it can show you the events around you. And we needed to be concerned about veterans concerned about their privacy who want to use the app but don't want to feel like they're constantly being tracked by like Bluetooth and location services.
So for our front end, there was quite a bit of deliberation on what we wanted to use. Different members of the team had experience doing iOS development and Android development, and we were kind of fortunate in the sense that in terms of languages meant for specific or more acclimated towards specific native platforms, we had a pretty even split. But we have a single client code base, and at the end of the day, we're a development team of 4. We have a back end, we have our front end, and then all the requirements, every design document that has to be written, and the amount of paperwork that we have to do, especially starting this from scratch. We all had a little bit of web experience, and some of us had even written some React Native code before. So we decided for the front end of things to do it in React Native. This also kind of played into the legacy of the project. So this project's development span is, and we knew this going into it, is going to outlive us at RIT. It's going to be a senior project next year, and it is going to go on for a substantially longer amount of time. And having to just learn one language to develop for both mobile platforms seemed like a really, really good idea for us to go. We all knew how to use the web, so one client-side code base divided by 4 developers is a lot better than splitting it up, especially since we still have a lot of back-end stuff to write and we have a lot of logistics to manage. And for that reason, we decided to do our client in React Native.
As far as the backend concerned, there are a lot of web frameworks, there are a lot of databases. Ultimately, we decided to choose our database. That's how we started, was looking at the database, what data we needed to model. So location being a big requirement, narrowed it down to basically 2, which was Postgres and MongoDB are the primary ones that support like queries like find me restaurants within this radius. So we wanted Mongo basically just because we need to rapidly, requirements change, so we need to, having a schemaless NoSQL that just allows us to add and remove properties as necessary without having to migrate and do that kind of things. Why we went with Mongo. From there, the main contenders for the server itself were like Spring Boot with its Java or JavaScript framework, which plays much more nicely with the NoSQL aspect because you can just dump in JavaScript objects. So yeah, that's how the backend works. And then we're authenticating it all with Firebase SDK, which has a lot of good methods to use on the client, which persists user data, handles caching for you, and that sort of thing. And given the privacy aspect, we didn't want to have to handle our own user authentication. For testing, we currently test all our API requests in Postman, which, for anyone unaware, is just a software you can use to write HTTP requests and automate the tests for them. Eventually, we'll probably have some sort of CI that runs those whenever we submit them, but for now, it's manual. We have QA on all stories, so anytime someone submits a commit, 2 other people have to verify that it works before we accept it to the master. And we do validate all our requirements with the sponsor at the weekly meeting, so we demo our thing for them to make sure that it's up to their standards. Moving forward, R3 is when we start our beta, so then we'll have users which can test for us. So far, we have release 1, which was a 6-week iteration beginning at the start of the semester. This was a short one, so it's just a proof of concept for now. Mostly just mocks out the UI. It does connect to the database, and that's pretty much it so far. It has an unfinished style. Going forward, we split into release 2, which is 12 weeks, and then release 3, which is another 12 weeks. The goal of release 12 is to solidify the style across the app and add full functionality for all the baseline features, so resource creation, retrieval, searching. Pretty much at the end of that, we'll have a working product. Release 3 is basically stretch goals that are still in scope, but not critical to the functionality of the application, so gamification, badges, and make sure that it's consistent across both platforms.
So for our process methodology, we decided to base it in Kanban. The main reasons for this were that it limits the work in progress, which helps to change requirements. You know, as requirements are changing, we're not going to have a lot of things that we're working on at the time. And even if we're working on something and then talking to the sponsor about it, and they decide that they might want to do it a different way, then we're not going to have a ton of things that we have to go back and change that are already in progress. It gives us a lot of visibility for the sponsor with our Kanban board, which we're using Jira for that, and I'll get into that on the next slide. And then also for schedule estimation, we can sort of use the metrics that we have on Jira and through our process of recording the time it takes to complete stories to estimate for the schedule for the future releases. The one major change from a normal Kanban implementation is that we have longer release cycles where the releases are 6 weeks and then 12 weeks and 12 weeks. We did this because the sponsors didn't really need a full release since there are no users right now and we're building it from scratch. And then a couple other considerations that we had for methodologies were Scrum and Spiral. The main reason that we didn't go with Scrum was that there was going to be a lot of process overhead with weekly or bi-weekly sprints that we didn't want to get into, especially since none of us had a lot of experience doing that in the past. And then with Spiral, we would end up with set requirements for each iteration, which we wanted to avoid because we don't really have a clear picture, a fully clear picture of what exactly we want, and we're expecting changing requirements throughout. So we didn't want to box ourselves in on that. So for managing the requirements, we're using Jira. We have epics that hold the feature stories, and then a defect epic which holds bug stories, and we add to that as we progress and find any new bugs. The client has access to the board, and then using Jira also helps with tracking the time to complete stories and then sort of organizing the stories into releases. Here's just a look at our Kanban board on Jira. The workflow consists of developing, code review, and QA testing, which Matt already talked about a little bit. Once the story is developed, it goes to code review, someone code reviews it, and then it gets merged in, and then someone has to test it before we actually close the story. And then we're utilizing limits on the work in progress to make sure that we don't end up with too much in progress at one time and make sure that we're keeping a good flow of stories. So for scheduling, we're using the previous story completion to sort of schedule out our next releases. During the first release, which was 6 weeks, we completed 35 stories. So for release 2, we've planned out about 55 feature stories and then allotted just a bucket of 15 defects, as we expect to find defects as we're creating or completing stories.
As for the metrics we're tracking, as for our process metric, that would be the story time tracking per iteration. So anytime you complete a story, you just add the amount of time, and we just make sure that we keep it consistent. For product, that's not going to take place until we have users during the R3 beta, but we feel a good metric would be the average events browsed per week, just because that's pretty much the base functionality of the app, and it'll give us good insight into how engaged the users are.
All right, so for RM, we have a living risk table that we update as time goes on, because this is a very young project and risk really evolves with it. We're always finding new things to add in. So some of the key risks that are really applicable towards this project is, first of all, scope creep, where there's still conversation of where the app wants to go in the end of things, and there's different modifications being made. There's a risk that it could grow out of the scope we initially allocated for it. So we have to keep that in mind, and we have to plan accordingly. One of the perks of being so young into this is we could really build it so a lot of stuff could be added in, but at the same time, where new ideas could be added in at really any time, it could hinder some stuff we've already done. Addition of requirements, the same type of deal. Just if the client wants something to be added in and it's a good time to do it, or they just want it quickly, it could throw a hindrance into things. That's another thing that we have to take accountance for in planning out our releases. Cross-platform consistency, that is, we're primarily developing this on an iPhone, on an iOS device, and just planning out time for debugging Android-specific things is always going to be a concern as we move through this the way we are. And then privacy concerns is huge. There's always privacy concerns, and just keeping that in mind could set us back in time, and it's also a risk we have to keep in mind. So for interim reflection, I think it's pretty safe to say we call this a successful learning experience. And what I mean by that is the client was satisfied with what we did. They liked the quantity of the work, the quality of the work, and they said we exceeded their expectations. But at the same time, there were definitely issues that arose with the process of things, and we need to refine some stuff and fix some things to move through the rest of this project. If we keep putting out the output of work, there's no real doubt, and I think any of our heads, including the sponsor and our coach, that we will be a successful team and give them what they want, but at the same time, we could be better in terms of methodology and how we go through things. So right now, we were having some issues with the demo, so this is I'm going to try to get the demo going up on my computer. This is a Chromebook we presented off of. It just was not recognizing the HDMI when we were initially setting up. So we tried restarting it. We have a display port as well. And we're going to try to show you guys what we currently have. So, Chris? All right, first try is with the HDMI, fingers crossed. Hey. All right. There is other stuff on the screen.
Like, you have to pull it over.
Hey, there we go. Cool, cool. All right, now I can't see it. So, all right, this is awesome. Anyway, so this is our app as it currently stands. So what I just negated out of showing you guys is obviously there's an authentication flow. Right now users exist, users can be created. There's no real need to show your sign-up flow or our login flow. It's pretty standard issued. Right now when users are being created, their accounts are made with a mixture of actual data and dummy data. The connections are made as we build more fields in our database. More fields in our database will exist, and in the same way, when those are created, there'll be less dummy data displayed back. But right now, you can create a user, and some of the fields are live, some of them are not. And when you create an account, it is going to land you right here on the screen. So this right here is going to be a monetized ad, and it's going to be a slider of monetized ads. We don't have monetized ads yet, so there's a picture of a helicopter that is holding the space of one. Right now, all our settings is up here is just a sign out screen, and if you head over to the profile, this is a rough cut of what our profile is going to look like. So this is my test image I use for everything. I'm going to turn around right now. So, the 2 minutes was for demo included?
Yes.
Oh, my bad entirely. Okay, cool. Then I guess we'll open up for questions. Sorry about that.
Questions from the audience?
I have a question. So, going back to your methodology, you said you chose Kanban, which is an agile methodology, correct?
Yeah.
But you chose 12-week cycles. Doesn't that seem to kind of go against the principle behind agile?
They aren't necessarily cycles as much as in Kanban we have releases, and that's just when we're giving a sort of finished usable product to the sponsor. Prior to that, we don't really have anything in the middle for them to get. So
Why did you go with the agile methodology if you're not going to be given relatively frequent releases?
because we're going to be, we meet with them weekly, so we like to get feedback weekly, and there's also, we're sort of forming the requirements with them as we run into problems developing, or they decide that they want something changed while we're talking to them. And we, as a team, rather than them giving us specific requirements, we sort of come up with them during our meetings and sort of flesh things out.
Along the lines of your validation, what are some of your plans as far as testing this out with real users? How will you be developing that?
So in terms of getting this in the hands of real users, we're working with the sponsor that is their business plan to get us to develop something that they're going to put in the hands of real users over the summer, and then the real users are going to come back with feedback, which is for the next development team. So right now we're building this for their specifications, and they're putting it in the hands of real users at the end of our development with it. And their beta will be our final project at the end of this.
So why did you choose, I think I saw you use Vue.js for your dashboard, but you're using React Native for like mobile development. Like why did you choose React.js for the dashboard?
The person who spearheaded the dashboard was just very proficient in Vue, and it was in the early stages of it. And there's not really going to be there's not intended to be too much cross between the two of them. Like there won't be any real relevance developing those separately. Yeah, so the initial requirements came from the sponsor, and we helped them flesh them out into like requirements for the application. So there's, yeah.
Well, it just seems to me sort of the focus on gamification and privacy almost are, diametrically opposed. I'll be interested to see how that plays out over time.
It will be.
Let's thank the team.
team working on the writing styles improvement application. I'm Donald Deep.
I'm Adam Spindler.
I'm Musab, Eric, and Steven.
So today we're going to start off by giving you guys some insight into what we're doing, how we're doing it, and why we're doing it. Talk about some of the testing that we did over the semester with users, give you guys a brief demo of what we have so far, discuss some of the metrics we've gathered from our testing, and just throughout the term, and talk about our overall team progress. So a little bit about the domain of our project. A lot of non-native English speakers, such as people who are foreign, learn English as a second or third language, etc., hard of hearing students, when they take English classes, there's a heavy emphasis on being grammatically correct. This leads to, while the writing style is correct, there's a lot of deficiencies in the voice of the writing. It comes off as awkward or choppy or as the wrong tone, so it's often misconstrued. So, and online right now, there's not a good interface for people to get feedback on the writing style, but there is for grammar. So what we've been asked to do is to provide an application for users to get feedback on their writing style and hopefully improve it. Our requirements can be summarized into these main features: providing real-time feedback on people's writing styles. And a writing style is a very broad subject. So it was broken down into 4 key components. Restriction clauses, which might be, he went to the store because he was hungry, would be a proper sentence. Whereas somebody who learned English as a third language or second language might write, he was hungry and he went to the store, which, while is grammatically correct, isn't the most fluent or flowing. Reversing sentiment. A piece of writing might overall be very positive, while something in the sentence in the piece of writing is very negative, and there's no real reason for the juxtaposition of the negative sentiment in that sentence versus the overall positivity of that body of writing. Word choice improvement. This one's kind of explanatory, whether it's using informal language or just there's a better fitting synonym to make the sentence less choppy. And then rearranging sentence schemes. That one's also kind of explanatory. And then a less feature-driven requirement is just for us to use a cloud service. Our sponsor asked that she'd prefer us to use AWS, and that our web app would be able to be deployed fast. So gathering requirements over the semester was a very easy process. Initially, the project proposal had very well laid out requirements, and they were very explicit, so we didn't need to do much clarification on that. However, we felt like, due to our backgrounds in natural language processing and machine learning being very minuscule, we didn't feel like we'd be able to achieve all of those features that were asked for. So initially, we started off by just prioritizing requirements and figuring out what we could do in the time we were given. After that, we kind of broke down the requirements into 4 different categories, as listed there, and we realized that there wasn't a lot of usability requirements. So we did a lot of user testing with our demo and to gather new requirements, and we would take note of these requirements, and during our weekly sponsor meeting, talk to our sponsor, give our feedback on these requirements, and ask for her final decision on whether or not it was worthwhile to invest time into completing those requirements. So this is our domain model for the current iteration of what we're focusing on right now, which is just word choice improvement, because we felt like that was the first and easiest thing for us to accomplish. So we broken down a writing sample into a sentence, which breaks down into a word, which breaks down into many things such as synonyms, words of formality. We left this design to be flexible for in the future when we finish this word choice improvement feature for sentences, since the other 3 features really have an emphasis on clauses, which are part of sentences, but not necessarily words. And sentiment, which is generally both words and sentences.
For our process methodology, we chose to use feature-driven development because we wanted a process that was iterative, but not with all the overhead of Scrum or other agile methodologies. We didn't want to have to worry about maintaining a backlog or doing stand-up every morning. So we went with this one. And this also plays well into our usability testing scheme. So the first part of a feature-driven development process is you just understand the requirements, you understand the project domain, and then from that you derive a list of requirements. which we did, and then we talked to the project sponsor and had her prioritize those. And then you plan who will work on the feature. And then, as you can see, there are multiple stacks in the next step because people can work concurrently on different features. Yeah. Oh, actually, I should say, for usability testing, like this plays really well into it because like we would get new requirements from doing the usability testing, and then we would have those requirements reprioritized. So we'd go back to basically all the way back to the beginning because we really need to re-understand what our users want and make sure we're creating a project that they will actually use. So there were a few trade-offs in the design process here. The first one was to choose like what type of application we were going to make. A web application was the best choice, really. Most people do their writing on either a desktop or a laptop and not on like an iPhone or an iPad. So we chose to go with a web app. And we also made it have a reactive layout so that people can use this application on their tablet devices as well. And then for the implementation, we decided to use machine learning over trying to deal with heuristics in the English language because having all these rules and specific cases in the English language and coding that all up would be much more difficult than just giving a machine learning model examples of what we want and examples of what we don't want. And we used Reddit comments for examples of what we don't want, for improper writing, and examples from academic papers for good writing, well-structured writing. And for a GUI, we decided to use a light front-end framework instead of going with something heavier like Angular or React because it was pretty simple. There are only a couple pages on the main page, and I did most of the GUI coding, and I just liked being able to mess around with the CSS and dig right into it. Yeah, so some strategies for our implementation. We initially created the GUI prototype we created a GUI prototype so that we could show the sponsor exactly what was in our heads when we read through the requirements document, so we could get on the same page about what we were actually trying to deliver. And we just looked at similar software in the field and based a GUI off of that, and then went through a couple iterations amongst ourselves as a team and with the sponsor. And she gave us some suggestions for improvement, and we made those improvements. Then we went on to do some usability testing, get some requirements from people who would actually be using our application, and we did a couple iterations on that as well. And then when we were doing the implementation, we tried to split up the work amongst people who had experience in the areas that they would be developing, and we split it up also so that people could be working concurrently. They could be working on different things and not stepping on each other's toes, which is really important. And yeah, we obviously spent most of our time working on requirements that were marked as high priority by the sponsor.
For our development methodology, we needed an easy and efficient to be able to submit to AWS. First, we commented our code on GitHub, and it would automatically build onto Docker an image, and in Docker, and that was in the Docker cloud, and then it was submitted to the AWS. The reason why we used Docker was because of the extensionability, and it was easy to submit or deploy. Docker management would be able to run the Python program with natural language processing, with the natural language processing library that could be uploaded to the website. And that was our development methodology. For testing, we had two types of testing. We had usability testing and we had code level testing. Our structure for the usability testing was to make an early prototype, and we wanted to meet our sponsors' expectations, and then gather 2 rounds of usability testing as well and make new user requirements from that information we gathered. For code level testing, we scored the number of errors in the natural language processing. Like, we would group words by human errors, more there's more details in the next few slides. The issue for the usability testing, we had quantitative for scores, and for the surveys, as you can see, they were scored for numbers, and then qualitative as well. And that's how the person typed comments, and that was their subjective opinion. And we wanted to balance both of those. And how to actually gather the data, that was a challenge for the testing. The other issue was the neural net, the artificial intelligence. We didn't know if it would function appropriately with the results. So we had to self-report the analysis to make sure that the results were appropriate. The usability testing details. Before the usability testing, we posted flyers on campus, and we actually showed up in a writing seminar class to recruit students that were interested in signing up to test our product. The efficiency of signing up, of showing up to class to recruit, actually helped us because the students could see that we were actually developing this product. So we had a core group of 6. We had 4 deaf and hard of hearing students taking writing seminar, 1 native English speaker, and 1 faculty professor who taught writing seminar. During the usability testing, we were allowing the students to play, or the users to play around with the app. And after the usability testing, they filled out a Google Doc, and we made new user requirements from their feedback that they provided. So this was the flyer on the right-hand side, as you can see, for recruitment. This is, in the first round, one question was, did the website accomplish what I wanted it to do? In the first round, it was 33% were not satisfied and 33% agreed. So it was really a poor result, and after we made user requirements from that first round and applied them to the second round, our results really improved to 83%. In the beginning, you had to click the list to get the list of words, the word choices, and after the second round we changed to, you just could hover over the word and then it would drop down a menu of different words you could use.
Alright, now I'll show you guys a quick demo of what we got so far after we did all the usability testing. Alright, yeah, so you go on the main page here and you just basically paste in your writing sample that you have. One of the requirements we got from the users actually was that they couldn't find the Analyze button because it was all the way at the bottom, so I just made that always visible. And this is just like a random writing sample that I have in there right now. If you hit Analyze, you see that it does an analysis right now. This is all just like statically in there. But yeah, it'll show you, it'll underline words that have been repeated in your writing. It'll underline words that are informal, that it marks as informal, like snazzy. That's pretty informal. If you hover over it, you get some suggestions to replace it with, like professional. Seems more professional. And yeah, there's not really much to it. Most of the coding work is going to be doing the actual algorithm to like do this analysis here. But yeah, so far we have a pretty basic GUI prototype. It's important to emphasize though that this is just a prototype. No analysis going on here actually. But yeah, and we also added this feature to download a summary of like all the analysis that it's done. It'll show you like what informal words it found, what formal words it found, stuff like that. So.
All right, lower. Related to scheduling, what our team did, we wanted to make sure that there was a team member assigned for each task. because we used feature-driven method model, we needed to develop different classes. We needed to develop sequence diagrams and class diagrams. So each feature was ranked and on how complex it was.
We use ranking requirements to prioritize each of the tasks.
We tried to find the best way to prioritize from highest difficulty to lowest difficulty. We went through with the sponsor, and she did all of the requirement management. We had 2 cycles this semester related to each usability testing that was recently discussed. Tasks were divided into 3 groups. That helped us determine which tasks to do first. The risk management, the 4-up was really very surprisingly helpful to us for risk management. We also made sure that each team was accountable for reporting their progress, because feature-driven methodology really emphasizes team assignments for each feature. We had pairs that were responsible for each feature. So that way, we held each other accountable. We noticed that there were 2 broad categories of risks that we addressed, and that was helpful in the project was requirement management, which means the user requirements and making sure that that went through the sponsor. And the usability testing recruitment was a big struggle for us, so we wanted to make sure that we approached that early and often. Our project metrics focused on the risks, the rate of requirements change, and those are highlighted, and those were changed as we went through the usability testing. The process metrics, again, was errors for natural language organization. So common mistakes like formal word, like the word kinda. It's not really formal, so that word would show up on the website. Obviously, that is a human error. So it would show different categories of errors that would happen, and then they would be put down. The overall team progress, the accomplishments, we completed a database in the back end, the AWS. We built the machine learning classifier and training data, the informal and the formal data. We completed the prototype and conducted 2 rounds of usability testing. We also refined the website based on the user feedback that we got from the usability testing. What we think worked well was the GUI prototype. We were able to get that quickly to the sponsor and the team, and we were able to all be on the same page. Also, we could reuse most of the HTML and the CSS for the real application. The usability testing was great. We got requirements from people who would actually be using the app. And what has been problematic was working on the machine learning, the initial learning curve with becoming familiarized with NLP and machine learning in general, and the initial recruitment for users was also a struggle. What we have learned so far, well, new requirements overwhelm developers sometimes. And we learned that you gather possible requirements from the users and have a central channel, like the project sponsor, to be able to approve them. We faced difficulties with recruiting users. We showed up to their classes and were able to explain our project in person. The scheduling lesson was to send emails early and often to make sure that we could schedule appointments. And also the budget influence implementation time. We revealed the budget estimate early and refined through the development process. And we worked closely with the sponsor department to set up the web service account. Does anybody have any questions?
back end with like an actual web server involved, and that'll be hitting up databases. And,
Yeah. Is there any consideration to use maybe a directed web application for your product, or is that not an idea?
that was not an idea. That is, I don't even know what that is. So. No, that's just hosted on the SME web servers.
Yeah. Currently, the only thing our AWS account that we have to get a budget approved for through the NCID department, currently all it stores is the database that we've classified a bunch of words with the formality score through our classifier. Right now it's just Postgres. We did consider RDS and Aurora, but unless if Stephen wants to expand.
We use MySQL for the database, for the storage, for the word, for the formality and the informal words, right? Did you want to, I think your question is more about the technology part of AWS, am I correct? Eric is asking? We use the standard storage for AWS.
What's your focus for next semester? What's missing? Looks like it works.
Yeah. Well, there's no analysis in place yet. Like we have a database of words that have like a formality score. We still have to like hook up the web application to the GUI portion. Yeah. Right now it's just like you can't actually type anything in there and have it analyzed. Just there's that one example.
And to expand on that, we're not entirely. We know we're not going to be content with the current accuracy of the algorithm we use to classify the formality of the words, even though we are using arguably the largest available online corpus for professional writing. Mainly due to our inexperience in developing actual algorithms to evaluate the formality score. While there are algorithms like the Bayes algorithm for positive and negative sentiment, that's different from being a formal or informal word. So we're going to take a deeper look into that too once we integrate the machine learning analysis for words.
Let's thank the team.
Yeah. Hi, so we're Team Freebird. I'm Austin Hartnett.
I'm John. Ian Montgomery. I'm Nick.
So this is a Arabidopsis plant. It's what's called a monoorganism, meaning that it shares a lot of the same DNA as a lot of other plants. And so basically what we can do with it is we can take its gene and gene sequences and model them and kind of infer facts about these interactions between genes, and we can kind of infer the applications that would happen for other plants. So Phoenix Bioinformatics, our project sponsor, is a California-based company that specializes in the field of biocuration, meaning they read these scientific research papers and they kind of highlight the key information about these genes or gene interactions and annotate them and kind of boil them down to their base components. The problem with this is that it takes a long time to kind of go through these scientific papers and kind of scrape the key information about it. So the solution was to create an online tool that allows the researchers who actually publish these sort of papers to be able to do it themselves and enter this information. So this is kind of like a rough view of our domain model. There are 3 actors in it. You could be a researcher, an admin, or a curator. They can all create, search, export these different gene annotations, and all of these can be approved by a curator, and then the admin controls everyone else. So kind of our project scope is that some features that any kind of user can create any specific sort of gene annotation. All different account types have different sort of permissions. And some new features is that we're kind of adding a new kind of pending process, meaning that there is a little bit, you can't just add an annotation to our system. It's more of it has to go through an approval process, through curation and stuff like that. You can also search for any other specific gene sequences, seeing if there's already a research paper that's already covered the specific gene sequence, and exporting these kind of annotations. So for requirements elicitation, this was a project that has gone on through 3 iterations of senior project. We are the 3rd team, so a lot of the requirements were mostly fleshed out in our project plan. So what we did is we kind of went through the project plan and kind of picked out the parts that we needed to work on and kind of passed it off to our project sponsor, where we went with them and they went through and assigned priority to each sort of requirements that we needed to hit also.
All right, so this is our overall system architecture, and our backend is a Node app, and we use Express for all of our routing. Our database, we're using a Postgres database with Next to construct our queries, and Bookshelf is our ORM. The big thing to note here is that we've got these external services that we have to talk to for information about like the plants and publications and stuff. So we kind of wrap all of those into our web app, and our front end, which is an Angular 2 front end, only talks to our back end. And then Orchid is our authentication system, which is a service that a lot of the scientists already have. So we authenticate using their system, so they have an OAuth protocol and everything for us. All right, so for implementation strategies, our big focus was making the current code more maintainable and readable for the next group. So when we picked this up, the front end was a huge React app, and it had this massive Redux state, and it was really, really fragile. So for example, any time you tried to make a new feature or something, you kind of risked messing up the current web app state and leaving it in kind of a borked future state. So for the first, we'll talk about this more in depth, but basically we just kept experiencing regressions whenever we tried to make changes to this. So we actually kind of refactored the whole thing, and in Angular, we focused on making all of the interactions really simple. So a lot of this whole Redux store pattern was replaced with Angular services talking to various components. So as we say, functionality increased 1x, but hopefully the readability and maintainability has increased 10x. So here's an example of what I'm talking about. On the right, you can see a picture of our main annotation page, and up at the top, you have to enter the publication ID. And one thing that we do while you're typing is check to see if that's a valid publication. So on the right, you can see there's a little red sign that says, oh, this is not valid, or a green one that says it is valid. In the previous implementation, this was really hard to even wrap your head around, but it's not a hard concept. So we replaced this kind of complicated, it actually follows the Flux architecture, but it's kind of just like this state that recurses on itself, which was the React Redux way. And we replaced that with one service and then one component that talks to the service about whether or not this publication is valid. And we found that this was a lot simpler to look at, and it's a lot easier for us to use in various places without worrying about messing up future state or anything like that. All right, so for our testing strategies, for the back end, we're focusing on test-driven development. And that just means, we have a new feature we want to add. On the front end, we might make a dummy function to try and do that feature. So like, for example, adding a role to a user. This is similar to something you might do in Postman, but we already have a front end, so kind of use that. And then as long as you set that all up with Express, you should be good to get just kind of a dummy response. And then the goal is you go in and implement the back end without changing your test up front. And then if you've done it well, as soon as it's done. And then another thing we're doing is we're using a pull request so that if someone wants to submit a new feature, at least someone else has to look at their code and approve it before merging. And then that would go onto our staging server. So the staging server pulls these new, the branch for staging that we've merged into. And we run this, and that's what we show to our sponsor for validation and verification.
All right, that brings us to the development methodology that we've decided to use. We went with Scrum. The reasons we chose this were because the sponsors had some requests that kind of point us towards an agile methodology. Specifically, they requested frequent prototypes once new functional requirements were starting to be delivered, because they want to be able to show those to clients to get feedback on any new UI changes that are put into the website. And another reason we chose Scrum is because everyone on our team has used it in a professional environment before during like co-ops, so it was something that we've all just had experience with. So we're using a pretty standard form of Scrum. We have 2-week sprints, storyboards, and all the user stories. We have a Kanban board, which is through Git. I'll talk a little bit more about that. We have a burn down chart, which is our process metric, and I'll also get to that in a few slides. We do sprint retrospectives after every sprint, kind of look at what went well, what went poorly, where we can improve. And then we do daily stand-up messages through Slack. So up on the board is kind of an example of one of those stand-up messages. We have, I guess, like what was accomplished yesterday, what's going to be worked on today, any blockers that are kind of going on at the moment in those Slack stand-up messages. So for estimating the story points and the user stories, we use Planning Poker. I'm sure a lot of you know what that is, but just in case, it's everyone has cards with a number in a Fibonacci sequence. That's 1, 3, 5, 8, 13, and so on. And then they all choose a card and for how many points they think that story would be worth. And then if there's any differences, it's discussed until there's a consensus made. So for our estimations, and then we did an initial estimation for all the requirements when we first got them. And then we've kind of been updating that as we went on and got a better idea of how long different pieces of the project actually work. So for requirement management, this is 2 of the columns that are in our GitHub Kanban board to keep track of all the tasks and tickets for all the user stories. So the last team that worked on this actually was also using this, so we built off of their project. We took their old issues that were left over and then created the new issues for some of the added requirements that we'll be working on also. Each of the tickets has the title is a brief summary of what the ticket is, and then the description has the points, the user story, the acceptance criteria, and then any other notes about the task. And then each of the issues have tags for if it's back-end work, front-end work, what the priority is, if it's a spike or not, what sprint is being worked on, and all that kind of information for quick glances of where the work is. And then the columns that we have are to do, in progress, and then sponsor approval. So they'll wait there until the sponsor approves them, and then they'll be moved to done. So for our first metric, this is our product metric. It's called Maintainability Index. It's a metric that we found through a metric plugin in Visual Studio Code. It's a value between 0 and 100 that is intended to represent the ease of maintaining the code. The higher the number, the better the maintainability is, and it's based off of 3 other metrics that are used. The first is Halstead volume, which is kind of a representation of how effective algorithms in the code are. So it looks at the number of operations that the algorithm performs and how many operands in the algorithm there are. And so then there's cyclomatic complexity, which is the number of linear connections between objects in the code. And the higher that number is, it's kind of a representation of how of the more complex the code may be. And then the third metric used to create this maintainable index number is just lines of code. So that's just the total lines of code in all the files. If the number between 0 and 100 is less than 10, that's a red and bad rating. If it's 10 to 19, that's yellow and like average. Greater than 20 is green. Our score is currently at 78.8 after the Angular refactor that we mentioned before, so we're running pretty well there so far. And then the second metric is the burn down chart for the process metric. So talking about this one, we started our sprints about 2/3 of the way through the semester after we got all the documentation down and our process set up. We very much underestimated how much time it was going to take trying to learn this other team's front-end React Redux system. That was basically what held us up. So during the first sprint, which is the blue line at the top, you can see that basically we started off trying to figure this out, and we got a little bit of work done, which was mostly just updating packages that had vulnerabilities that had been identified within the last year or over the last few months since the last team was working on it. But then continuing on through sprint 2, it was just a complete roadblock as we were trying to figure out basically how to work with this code system. So towards the end of sprint 2 is when we decided to start the Angular refactor. So, and at the beginning of sprint 3, we created a spike to get that Angular refactor done. And then towards the end of sprint 3 is when that was finished up, and now we are able to start working on more functional requirements that we have story points for. So that's that little drop there, and kind of what we're planning on for the future.
Okay, so some of the risks that we worked with, well, actually, in terms of identifying risks, the weekly follow-up chart was a huge success. Really kept us in mind of all the teammates and made sure everyone was on the same page, not only the group members, but also the sponsor. One of the awesome mitigation strategies we actually had was all project sponsor has a technical expert, Treelock, and he was super helpful in talking over things like Angular refactor is obviously a massive risk. And so be able to talk through with someone that knows has more work experience than us. And so we understood all the parts that would go into that and whether or not it was worth our time was very useful. And obviously there's risk associated with handling code, and we're doing our best to make sure the group that won't have the code after us will have a different experience than what we had. Okay, so some of the results from our thing. In terms of actual group work, we're really in the norming stage. We're trying to, we're working together a lot better than in the beginning, and we're understanding our strengths and weaknesses. A lot of the thing just came from learning the domain knowledge. It was a little bit to understand what was going on, but our sponsor actually did a great job and explained to us the importance of doing this and all the information we need to know to work on the site. One of the big results, obviously, is a pretty new front end. So it's an Angular front end that all of us actually understand, which is very key, and now can contribute to work much faster in going forward. We have a cool little architecture for deployment in AWS, so we can show it to the client, and the client can show some of the other researchers the work. And just the knowledge of the sites. Obviously, knowledge of the code base is very important to be able to make new changes, so that's very useful. And then a quick reflection. A lot of this comes down, actually, we learned a lot from those metrics we took. Estimating amount of time was a sketchy business in the beginning because of a code base we didn't understand, and our estimations were very bad in the beginning. So as all Agile, we're trying to improve with each iteration and get more accurate estimates, not only of how much effort goes into each piece of the code, but how much we can do in a sprint. One of the big things is we need to split up tasks into smaller pieces. We really got caught up on that front end, and all of us were looking at it all the time, trying to figure out about it, and we missed doing work in other pieces. So if we can divide and get smaller things done, we'll get more work done overall. One of the things moving forward, now that we're not reusing HTML anymore and we got to create new stuff, we want to create wireframes and get the wireframes approved before we start
coding on them, so we don't waste time with coming up with kind of bad designs. As we're all software engineers and not design majors. And yeah, we just kind of remember that test-driven development to make sure the next group, once again, will have code that works and they know it works, and if they make a change, it's easy to test that they'll change and break anything. And pretty much after this presentation is done, we're ready to hit our stride and hit some of the bigger things that we want to get done, like finishing of our such, which is one of the main functions of the site. Cool. And any questions?
So you talked about how the switch to Angular was previous. I'm just curious what a couple other risks were and what your mitigation capabilities.
Well, a lot of like the base one was just coming from estimation. So like we did our best to assume how long it would take to add new features, and we didn't do a good enough job of researching all the tools beforehand, and that kind of caused stuff. So obviously now we're trying to we jumped into early with our sprints without understanding the code base well enough. So now we're trying to wait to do our estimation until after we know more information, and that's kind of a big thing.
I might have missed it, but how long were you guys in sprints?
2 weeks. Yeah.
What was the previous cyclomatic complexity?
What's the previous cyclomatic complexity?
For the previous maintainability index score, for the React Redux was down in like the 40s.
No, before you were working on the project, when you,
Yeah.
as you just
Yeah.
it was down where?
Down in the 40s. I don't know what the specific cyclomatic complexity score was though. That's the overall maintainability index score.
Thank you.
Does the fact that you're so far over the green line, does that indicate maybe a calibration issue with that particular metric?
I think so. My understanding of how it was a pretty complex algorithm when I was looking at it, but my understanding of it is correct. Once you get past that 20, it is easier to it kind of increases faster than it does at lower levels. So it's kind of easier to go higher.
The other way, so it's harder to get it really bad. It's easier to make it better. It's just a weird way to do it.
I mean, personally, I think it's a little calibrated funny because it doesn't feel like it was at all close to maintainable. So
frameworks also mess with maintainability to an extent.
Could you isolate a smaller part of the application and just use the metric on that part instead of on the entire code base?
That is a good idea. That we should definitely
A
do that.
A lot of it's probably code or library.
Well, I did remove all the libraries from it. There might still be a couple other generated code files I missed. I'll double check that.
So what information would you like from the other team to help with the coming up to speed?
Well, the other team, they actually on GitHub, they actually did have a very informative wiki that they tried their best to kind of explain how everything works. But even following their steps on their wiki, we still ran into kind of problems on how the entire thing worked. If you want to get into more...
I think that's kind of the problem the old team thought. They were like, we're going to make it so easy for them by having 4 or 5 pages of instructions. So it's like, yeah, that's great that you gave that, but it's like, what if you made a system where you didn't even need 4 or 5 pages? You just had run. You know what I mean?
A lot of the documents will how to get it set up, not how it works.
Yeah.
So that's one of the things we're gonna try and do is include sections of what each file does, and so it's easier to pick up.
Make it easier to set up instead of trying to go through what they did before.
Mm-hmm.
Other questions? Let's thank the team.
Hey everyone, we're Team Purple Draft, and we're working on the Cyber Advisor project for Gallerith. And you see here, this is our team. We have Kayla, Luke, myself, and Drew. Additionally, our project sponsor is Lee Fishman, and our project coach is Rick Weil. So now here you'll see our agenda. First, we're going to go over our project overview. We're going to follow that with our schedule and our process methodologies. After that, we're going to talk about our risks and metrics. Then finally, after going over our design changes and rationale, we'll reflect on the status of our project and what lessons we've learned. And lastly, we'll end with Q&A if you have time. All right, so what is Cyber Advisor? So as we all know, our climate of modern computing is rife with cybersecurity risks and vulnerabilities. These can range from like really simple things like leaving your laptop out unattended in public, to like the very hardware that's shipped with your device containing backdoors for malicious actors to abuse. For a technical person like ourselves, understanding these vulnerabilities can be difficult, but it's doable. However, for the uninitiated everyday person, this can be like an insurmountable task. That's where Cyber Advisor comes in. We're looking to provide an online tool that allows users to help understand their vulnerabilities. By having users fill out a comprehensive survey, we're able to use a powerful set covering algorithm to create a model of the attack surface and provide users with the appropriate security recommendations. Ultimately, our goal is to empower all users with the information they need to keep themselves secure in the digital domain, regardless of their background or degree of technical proficiency. So, we inherited Cyber Advisor from a previous senior project team. Currently, Cyber Advisor is a C# ASP.NET web application that's composed of 3 parts. So first you'll see here is that we have like the home screen. It's supposed to be the entry point to the survey. After that, we have the actual survey itself. We have digital assets listed out, which include things like home PCs, routers, social media accounts, and many others. They're divided in categories that you can see at the very top. When you select whatever asset that you have, questions are populated there, and it forms a comprehensive questionnaire that exposes all particulars of a device for our algorithm to transform into security recommendations. Lastly, we have the results and recommendation screen. Using the set covering algorithm implementation, users receive a list of recommendations which direct them to what they can do to better secure their assets.
So as Johan said, we did inherit this project from another senior project team, and what that team produced was a minimum viable product. They have a front end, a back end, a set covering algorithm, and results that come out of that. So what this goal is for this iteration of the project is to refresh the user interface, both logically and just from a visual perspective, and as well as to enhance the database schema, and also the just underlying architecture of the project is a little wonky. So we're just here to refresh it and make it ready for users to start using and go through some user testing as well.
So with our task and scheduling, so for our project we were using GitHub issues and projects in order to keep everything that we're working on in one singular place, so we all know where to look for things that are coming up. Our estimations so far have come primarily based on our experience in our co-ops and some initial digging into some of the issues that we may not have experienced in the past. Our project board that you can see here gives us and our sponsor a up-to-date look at the current project status, and it allows our sponsor a easy way to quickly shift our priorities if need be, or add new items into our backlog as we approach them. So even though we have our sprints, we have broken the project down into 3 main phases. Phase 1 was the initial ramp up. We did some back-end technology changes, but it was a lot of documentation and getting used to what the project actually was. Currently we're sitting well in phase 2, where we're actually jumping into the project. We're going to be developing out an API for our back-end. We're designing a new UI, and we're looking into making some changes in the database. In the future, we're going to be getting into some user testing on our new UI. We're going to do some refinement on all the new features that we're building. In addition, we have this additional features that's sitting there, and that's just a buffer in case something takes longer than we expect, or if any new features come up that we didn't anticipate.
And so I'll get into our process, and for our process methodology, we decided to use a Scrumban, which is a combination of Scrum and Kanban. This gave us a lot of flexibility because we had the relaxation of Kanban, more prioritized backlog, but kind of work through things as we can grasp them. And then also with Scrum, we have our daily stand-ups with the team, kind of just check in what we're doing. We meet with our coach and our sponsor weekly, and then we also have our 3-week sprints. So we decided to do sprints just to keep us accountable for things, because sometimes with Kanban, you can say you're working on things, but then when it comes to delivering them, you run short. So by combining those two, it gave us a lot of flexibility to do the ceremonies that we wanted to from Scrum, but then also to have the flexibility and the time with Kanban.
So jumping into our development methodology, since we were given a project that had functionality in it, first thing we did is we set up a continuous integration server so that any future changes we make, we know it's not going to break something that was already built into the app. So with the new features or bugs that we find in the app, each of them is going to get a separate issue on our project board for tracking, and as well as a subsequent branch. When that branch is ready to be merged, it's going to require a review from another developer before it can actually be merged back into master and added into the project. Here, project quality is actually maintained through our automated tests that are run on every pull request that we have in our system.
All right. So I'm going to talk a little bit about our risks. Big, really important thing is that we're asking the users for a lot of information about their systems. And while security through obscurity isn't really security, it's very important that we make sure that we maintain the security of their information. So that's a big risk. That's something that we have to consider a lot of, and there's been a lot of debate about even will we store that information at all, or will we leave that entirely on the client side, maybe some cookies, stuff like that. Another big, really important thing is the set covering algorithm is very powerful, but it's not necessarily going to return results. Just right off the bat, it's not necessarily going to return results that make sense for the user in their context, right? So a home user is not going to go out and purchase a multi-$1,000 IDS, IPS hardware firewall rack mount system because they're a home user. And so we need to figure out how we can kind of take the set covering algorithm and take the data that we have and ensure that it fits the user and not just all of the questions. Next, we also need to make sure that the survey questions cover the security space, right? It's difficult to just have a giant list of questions and that cover perfectly everything that we might need to know. And at the same time, we also don't want to necessarily have too many questions, or the user may get question fatigue and just give up. So that's going to be difficult to kind of balance that out. Finally, we need a variety of users. This is intended to target both home users and small business users. And we need to make sure that we need to find users that fit both of those bills, right? It's easy to get more home users, but finding the small business people is a bit tougher. And of course, we need to measure the the quality of the recommendations that we produce, which kind of ties into giving them appropriate responses, but is also more in keeping with potentially getting feedback on those responses, right? So maybe we implement a rating system. This is something that's that we've been talking about with our sponsor. We're not sure. We think it's a good idea and we want to consider it, but it's a big risk.
So, measurements and metrics. We're going with the GQM model for our metrics, and we have 3 that are tracking. First, we have usability and product quality. We want to ensure that users not only have a defect-free experience, but they're also delighted to use our application. To help us determine if we are successful in this or not, we're tracking unit test code coverage, and in the future, we'll obtain information from usability tests and surveys. Next, we have algorithm quality. A large portion of the success of the application is determined by the algorithm returning quality recommendations, as Drew mentioned earlier. In the future, we are looking to implement automated white box testing on our backend recommendations API, along with human analysis to determine if the recommendations is giving back actually makes sense. Then last, we have team productivity. We want to know if the team is adequately dividing resources to the appropriate areas, and if we're performing as expected. We've broken down the work and time we spend on the project into 4 categories. We have rework, refactoring, UI design, and documentation. We're also looking to keep track of the estimated time for task versus the actual time on the task. With those measurements, we think we can answer questions regarding if the team is performing well and pinpoint areas where additional time or resources are needed. So this is an example of the breakdown of the time we spent of the past couple sprints we've had. It's all just measured in hours. And as you can see here, currently rework and UI redesign have taken most of the brunt of our effort. But as we continue with the project, we expect there to be more time spent on documentation and refactoring. This other measurement here This other measurement here is for our unit test code coverage. The code we inherited, as you can see, from the back end controllers from the app, and the front end had 0 coverage whatsoever. However, the algorithm itself did have unit test code coverage. As we work through this and work on the app on our own time, we expect that our back end and our front end to have adequate code coverage.
So we faced a number of design challenges and changes as we've taken this app. As Johan mentioned, there's very little coverage or code coverage and a number of things that really needed to be changed. The first one is it started out as a .NET standard, ASP.NET standard application, and we decided to move to ASP.NET Core for a number of reasons. We really looked at this project and found a lot of things that were done sort of haphazardly, I think is the best way to put it. And with that in mind, we were looking at .NET Core as sort of a way to both ensure the future viability of the product and help us kind of ferret out and root out those issues that were going to pop up later. Really good one was sessions. Like the way they'd done sessions in ASP.NET Standard didn't quite work out. And ASP.NET Core really forced me to figure out what the issue was there. Anyway, so the reasons for moving to that are Microsoft recommends .NET Core for all new ASP.NET dev, unless you have a very good reason to use .NET Standard. .NET Core supports CLI tools. It supports Visual Studio Code. You can run it on Windows, Mac, and Linux, and in Docker containers, which is very important because our project sponsor, while currently a Microsoft shop, is interested in starting to Dockerize some of their stuff. And so this was very important thing. .NET Core also has very good support for single-page applications, React, Angular, etc. And we really thought that that was a very appropriate way to deal with this fairly complex nested UI style of stuff. Finally, we wanted to use the improved SQL database integration tools and libraries. .NET Core has the Entity Framework Core, which is their ORM. It's really nice. It does a lot of really cool things. And it made my life so much easier. And finally, we kind of realized early on that we needed to look at the existing project as a bit of a prototype. As I said, we ended up having to make a lot of design changes. A lot of things were done in a way that was appropriate for an MVP, appropriate for a prototype, but really wasn't going to scale out long term very well. And part of kind of moving out of that phase was changing to .NET Core.
All right, cool. So when we're rebuilding our front end, we decided to use React.js. So, the main reason for that is, we need to have a lot of fidelity interactive. So our front end needs to be very interactive. And in the last decade, we've seen that, complex interactive web applications don't really work so well from generated HTML. You can't really test them so well with like test-driven development or behavior-driven development because UI testing generated HTML pages along with the code behind like JavaScript is very difficult. Additionally, a single-page application will allow us to divide large portions of the functionality into the site into like independent modules that can be tested. And additionally, from doing that, we decouple the back end and the front end. So, in the future, if let's say, Gallup wants to, throw out the front end and do a UI refresh, switching technologies, at least, the API itself will remain. Then lastly, well, I guess, also by using a single-page application, you put a lot of the processing load on your client, which saves us, like, server cycles in the end. Then ultimately, our team has a lot of experience with React over other frameworks like Angular, which is ultimately why we decided to go with that.
And I'll talk about the UI refresh a little bit since this is a main portion of our project. These are some wireframes that we have. This would be sort of an interactive like landing page to introduce you to the product, which doesn't currently exist in the product that we inherited. We don't have a framework that we chose yet other than just Bootstrap. We'll decide that later on. And then some other pages that we have would be an updated survey screen that gives users more of a understanding of where they are in the entire survey and understanding just the timeline of when they'll get their actual results, saying what portion of your asset is at risk and sort of what you can do to fix that.
So going along with our shift to React, we needed to make some changes in the back end because the current MVC design was not really going to fit with what we were looking for. So in doing this, we had to create an API, and while we were doing that, we figured we'd update the database because its current state is not really that usable. So there's a number of good reasons that we're doing this. It's going to be easier for us to use. It's going to allow better extensibility and better automated testing. But
All right, so for our reflection, what went well? So early on, our team was really able to breeze through like the group formation stages, like just forming, storming, norming, performing. We would consider ourselves to be in the performing stage. And the way the labor is divided between our group, everyone's level areas of expertise are being utilized. Also, redesigning our front-end prototype went surprisingly well and did not take as long as initially assumed. What didn't go well? So we were given a minimal viable product, but it was kind of difficult initially to figure out what exactly to do. We didn't have the same business context or motivations as the previous senior project team, and to go off that to list the requirements of a sponsor could be quite difficult at times. Additionally, as with implementation of any new technologies, switching to .NET Core has come with issues in development. We've budgeted for that, but nevertheless, we expect that some other things may come up in the future. Lessons. Excuse me. Also, we've had some issues with communicating what we've been doing with our sponsor. We've been really busy with what we've been working on, but our sponsor coach at all times may have not been really aware of that. So what we have learned from that. So using task boards like GitHub Project show exactly what the team is working at times, and use that to guide meetings and be really helpful to show that, yes, indeed, we are doing work, and to be transparent with our sponsor. Then lastly, implementation of new technologies, they need to be thoroughly researched for their caveats, any known issues and bugs, and additional time needs to be budgeted for the implementation in the case that, issues may come up down the line. And that's it. So any questions?
So, I was a little curious about what you consider documentation, because you're relatively early in the process, and so I would expected a decent amount of time to be spent doing some level of documentation, either documenting requirements or something like that, but it seemed to be a relatively small amount of time, and you said that you were expecting that would go up later on, so you're not saving all your documentation to the very end, are you?
No. Okay. So when we say documentation, we're talking a lot about, so you saw that on the database slide, you saw the kind of database schema picture, right? A lot of the documentation is just stuff we're adding in as we go. Code comments, design documents, even stuff like, as Kayla and Johan are kind of the primary UI people, all these wireframes, all these UI prototypes and mock-ups, that's documentation, right? So it's not just code comments. It's not that we're saving it all to the end. It's sort of, we started out with very little. We started out with basically some source code. Here's a Visual Studio project, and some requirements documents and stuff, but it wasn't as clear as we wanted it or needed it to be. And though we didn't focus on it hugely in our presentation, a lot of that has been sort of mixed in as we go along.
We've also been following the SE curriculum, and so we've refreshed some of the 444 and 440 documents, and so we have those as well. And they're up on our website, even though some of them are still living or not finished at this time. Like user testing, we aren't able to do that at this stage, so that's something that we'll have to update later on.
Any other questions? Okay, let's thank the team.